Today we're going to calculate force, mass, and acceleration. In your journals, I'd like you to set up your title, your objective. I can calculate force, mass, and acceleration, and have a few moments with your starter, and I will review it. Okay, for your starter, you want to look at this image. It's called the marble drop experiment. It's asking you, during what part of the marble's fall does it experience an unbalanced force? Unbalanced forces cause the change of a motion. So remember, to change the motion of an object, you have to increase its speed by making it go faster, decrease its speed by slowing it down, or you can change the object's direction, and it would be an unbalanced force. So if we look over here, these are labeled. So this bracket is telling you this is where the speed increases. In this bracket, from here to here, this is where your speed decreases. And from this bracket, it's telling you your speed is constant. So once again, unbalanced forces change the motion of an object. So if we increase the speed and decrease the speed of the marble, we're changing the marble's motion. So in these two steps, we have an unbalanced force. So please write in step 1 and 2, they're unbalanced forces. The second part of the question says, where does the marble experience a balanced force? Remember, balanced forces is where you don't change the motion of an object. So the object is either at rest or in a constant speed. And in point 3, you see here, you have a balanced force because you have constant speed. So in summary, you have unbalanced forces here where the speed is increasing and decreasing, and then you have a balanced force where your speed is constant. In order to calculate net force, we need to look at our star reference guide and use the formula net force equals mass times acceleration. We're going to use this formula and the formula triangle to get a formula for mass and acceleration. So on your handout, I'll wait a moment or two. At the top of your handout, you have 3 triangles, and we are going to complete the formula triangle for each. So I will show you what your handout looks like. So we're just going to do the formula for force, the formula for mass, and the formula for acceleration by setting up the triangles. So this is graded, so you want to be doing this handout as I present the presentation. So here when we calculate force, this is an easy calculation because net force equals mass times acceleration. This is the given formula on your star reference guide. So I want you to write the formula kind of near that first triangle somewhere. And now we're going to set up the triangle. So we're going to put a T, a multiplication sign, and then division at the top and bottoms. We're going to place this formula inside the triangle simply by reading it. It reads mass times acceleration. Multiplication goes across, so we write mass times acceleration. The only place to place the F for force would be up top. So going to your paper, this is what you would write. You would just fill out that triangle and write force equals mass times acceleration here. Set up the triangle again. We're going to make a formula for mass. So let's do that on the next slide. I'll clear my slide. Now we're going to calculate mass. I'm going to do the same thing. So next to your triangle at the top of your paper, you always want to just write that formula that's given, but it's on your side there. So if you can rewrite it, that would be great. So again, that's what you're given, but this time we want to calculate mass. So we need a formula for mass. Okay, so we're going to use the formula triangle to give us the formula for mass. Multiplication goes across. Please complete this on your triangle. And we're going to put this formula in here to get a formula for mass. So mass times acceleration. Your force goes up here. We want to cover up the variable we're looking for. We're looking for mass. So I'm going to kind of scribble that out so you can see that we're covering that up, and your formula reads force divided by acceleration. I'm going to write force divided by acceleration. So now we have a formula for mass. Okay, and just make sure that's kind of written near your triangle. Okay, and then lastly, we are going to complete that last triangle. And again, this is our original formula. Net force equals mass times acceleration. But here I want to calculate acceleration, so I need a formula. My formula triangle is going to give me that formula for acceleration. Multiplication goes across, division goes up and down. Let's get this formula inside here. Mass times acceleration. Force up top. Okay. And you want to cover up the variable for acceleration, and you have force divided by mass. Okay. So I'm going to clear my screen. Okay. And now we're ready to complete the rest of the handout. So on your handout, we're going to be looking at this chart here, and I'm going to walk you through these questions, and then we're going to do the same for the next part. So you have the handout there, and I'm going to give you time to do it as I walk you through a little bit, but you'll make the calculations using your calculator. So here on your paper, it says a group of students conducted an investigation to determine how the force applied to a toy vehicle affects acceleration. So here's their experiment. They have some toy cars, and they're applying a force and looking at the mass and acceleration. So we want to know which toy car had the greatest applied force. So we're going to be calculating the net force for each toy car. All right, so I'm going to go to the next screen. This is your setup. So I'm going to help you out with that. I'm going to minimize here and grab some web paint. Okay, so what we want to do is we want to calculate the applied force on each car. So this is what they're giving us. They're giving us the mass, they're giving us the acceleration, and they want us to calculate the applied force on each car. So this would be just Newton's second law of motion, which just states net force equals mass times acceleration. So I'm going to go ahead and write that formula right here. Net force equals mass times acceleration. So what you're going to do, here's your mass, here's your acceleration. You're going to multiply mass times acceleration to get your applied force, which is measured in newtons. So take your calculator, 0.2 times 2 equals what? Go ahead and fill that in. Okay, so down here on B, we want to calculate our net force here. So net force equals mass times acceleration. Here's your mass, here's your acceleration. So 0.2 times 3. Put your value here, that's in newtons. Okay, and you're using a calculator if you need to. In part C, we have net force, which is your applied force on the little toy car. Here's the mass of toy car C, and here's the acceleration. So mass times acceleration. So 0.4 times 1, put your answer there. It's measured in newtons. Forces are measured in newtons. Okay, and now we want to get the applied force on car D. So our applied force, our net force being applied on the car, we want to do mass times acceleration. So mass times acceleration, okay, and then put your answer here in newtons. I'm going to go back here and we're going to answer these questions. Which of the toy cars had the greatest applied force? So looking at your data table, what applied force had the highest number? So which toy car had the highest applied force? That's what you're going to answer for A. And then it's asking you which of the toy cards had the same applied force. So looking at your data table here, I want to know which ones had the same applied force. And then lastly, did the force applied to the two carts result in the same acceleration? Now be careful with this one, okay, because when you look, you want to understand that objects with a small mass are going to have a greater acceleration than an object with a larger mass. So they shouldn't have the same acceleration because, again, objects with a smaller mass have a greater acceleration than an object with a larger mass. So I'll give you a few minutes to figure that out. Okay, and now going to our next questions. And if I'm going too fast, you can always just go back through to make your calculations. So try to stick with me. So it reads, two identical carts or cars are used with two different masses. So cart A has 1 kilogram mass and cart B has a 2 kilogram mass. A student applies a force to each of the cart and calculates the acceleration. So your force is being represented by this vector. So we have 50 newtons of force being applied to cart A, and then we have 100 newtons of force being applied to cart B. Okay, so they want us to compare the acceleration of the two carts. So what we need to do, first of all, is understand that this is a net force equals mass times acceleration problem, but they're asking us to compare the acceleration of the two carts. This formula is good for net force, but we need a formula for acceleration. So remember, to do that, we're going to set up our formula triangle. Okay, multiplication goes across, division goes up and down. Okay, so we're going to place this inside here. It reads mass times acceleration. So mass times acceleration. The only place to place the force is up top. Okay, and I want to find a formula for acceleration. So acceleration equals what? So cover up the variable you're looking for, and your formula reads force divided by mass. Okay, so now that I have my formula, I just simply plug in my numbers. So for cart A, my force being applied is 50. So you want to plug that in for your F. And remember, that's always measured in newtons. Your forces are measured in newtons. You got to have those units. The mass of my cart is 1 kilogram, 1 kg. So pretty easy. So 50 newtons divided by 1 kilogram. We don't even need a calculator for that. Our acceleration here for cart A is 50 meters per second squared. Those are my units for acceleration. So you would do the same thing for cart B. You'd use the same formula because we want the acceleration. So in this situation, you'd go acceleration equals, what's your force? Here your force, this time is 100 newtons divided by the mass. The mass of your cart is 2 kilograms. Okay, and you would do your division. And again, you can use a calculator, but we don't even really need one here. 100 divided by 2 is 50. So the acceleration of cart B is also 50 meters per second squared. So each cart has the same acceleration, 50 here and 50 here. Now, it makes sense because here you have less force being applied on a small mass. Over here you have a large force being applied, but it has a greater mass. Okay, so what we can say here is that larger mass objects do need a greater force. Okay, so less mass objects need less force. So going back to your question, I'm going to clear my screen. We can answer that. Okay, compare the acceleration of the two cars. So write to me. Okay, on your next slides, I'm just going to go through these. So here, oh, that was your formula for here. I wrote all on the screen, but you actually had a data table that you would have put that in for acceleration. You write your formulas and then your data here. Sorry about that, but that's fine. You'll have time to do that. Let's keep going forward so I can just show you and then you can go back and do your work. So here for this question, it's telling you a bowling ball rolled with a force of 15 newtons accelerates at a rate of 3 meters per second squared. A second ball rolled with a force of 12 newtons and accelerates at 4 meters per second squared. What are the masses of the two bowling balls? So here it's asking what are the masses of the bowling balls? So again, this is a force of motion question. So we're going to start out with Newton's second law, net force equals mass times acceleration, but we need a formula for mass. Okay, so over here I'm going to use the formula triangle. Multiplication goes across, division goes up and down. So mass times acceleration, I'm going to place that here. Okay, and the only place to put my force is up top. I want a formula for mass, so I'm going to cover up that variable, and my formula reads force divided by acceleration. So I'm going to write that there for you. Mass equals force divided by acceleration. Okay, so then what you're going to do is just plug in your numbers. This is your force measured in newtons, and over here these are your numbers for acceleration. So go ahead and do 15 divided by 3. You get your answer. And note how you have your masses measured in grams. Okay, so actually let's change that and make that kilograms, because grams is a very small number there. So make sure you have kilograms there for each of that mass unit. So here it's the same formula, mass equals force divided by acceleration, force divided by acceleration, and plug in your numbers. So I will give you guys a few minutes to do that. I'll clear my screen. Okay, and you can go back to your worksheet now and make sure you have everything complete. For your very last part of your lesson today, we're going to watch a video on Newton's laws of motion, and there's a separate link for that that will be played for you. So I hope you all have a wonderful day, and I hope that was helpful.